Hi, I'm Mudinda and I'm here to help you understand maths better for free. Today we're going to be kickstarting our lessons on factorization. This is particularly for grade 9s and grade 10s, but I know there are some grade 11s and 12s that struggle with factorization as well, and I really would suggest that you follow along with this series. To kickstart this, we'll start with common factor factorization. Let's jump straight into it. I'm going to use some illustrative examples to explain how to factorize. See, if you're given something like 2x plus 10 and asked to factorize, you need to look for a number or a variable that goes into both this term and into that term. In our case, that number would be 2. So you'd write 2, then you'd open brackets. Now, for you to know what to write inside of these brackets, you need to take each of these terms and divide it by the common factor, which is 2 in our case. Each of these terms and divide it by the common factor, 2 in our case. So we're going to take the first term, 2x, this term, and we're going to divide it by 2. When you divide 2x by 2, you'll find that the answer is just x. And if you take the second term, positive 10, and divide that by 2, well, 2 into 2 is 1, 2 into 10 is 5, you're left with positive 5, and this would be your answer. Let's take the next example. We have here 15x minus 10y. Well, what number or variable goes both into 15x and into 10y? I hope you're shouting 5. We're going to take 5 as a common factor. We're going to open brackets. Then we're going to take the first term, 15x, and divide it by the common factor of 5. 5 goes into 5 once, 5 goes into 15 3 times. So you're left with 3x. We're going to take the second term, minus 10y, and divide it by the common factor of 5. 5 goes into 5 once and into 10 twice. So we're left with minus 2y. That's the minus 2y there. So this is how you take out a common factor. Here's another example. 21a minus 14b. 7 goes both into 21 and into 14, so we can take 7 as the common factor. Now, if you take 21a and divide that by 7, 7 goes into 7 once, and 7 goes into 21 3 times, and so we're left there with 3a. Then the second term, minus 14b, if we divide that by 7, 7 goes into 7 once, and 7 goes into 14 twice. We're left with minus 2b. Now, you will have to be very confident with simplification in order to understand factorization. So if you haven't watched my videos on simplification, go ahead and give those a watch. Let's look at this example. X squared minus 2x. You see, in this case, the common factor is a variable, the variable x. 2 cannot be a common factor because 2 only appears here. It doesn't appear here. There is no 2 there, that's just x squared. We take out a common factor of x because x appears in both x squared and in 2x. Now, when we take x as a common factor, what will we be left with in the brackets? Well, if you take the first term, x squared, and you divide it by x, that's the same as having x times x over x. And so x can cancel one of the x's. What you're left with is actually just x. If you take the second term, the negative 2x, and you divide it by the common factor of x, the x cancels the x here, and you're just left with minus 2. I hope that makes sense. Let's look at a similar example. Here we have x plus xy. If we take out x as the common factor, when you take the first term x and you divide it by the common factor x, x goes into x once and x goes into x once, you're left with just 1. When you take the second term xy and divide it by the common factor of x, then you're left with just positive y. Let's look at this example. We have 3x minus 15x squared. Is the common factor here a number or a variable? Well, it's actually both. 3 goes into 3x, and 3 also goes into 15x squared. X goes into 3x, and x also appears in 15x squared. And so the common factor is both 3 and x. It's 3x. In our first term, we have 3x, and if we divide it by the common factor of 3x, would just be left with 1. In our second term, we have minus 15x squared, and if we divide that by 3x, well, 3 goes into 3 once, 3 goes into 15 5 times, x cancels one of the x's there, so you're left with minus 5x. Remember, when you have x squared over x, that's the same as having x times x, and when you divide that by x, you're just left with x, and that's what we have here, x cancelling one of the x's in there. And so this is what this factorizes to become. Great. Let's look at some more examples. Imagine we had 20a squared plus 10a. Again, the common factor is both a number and a variable. We know that 10 goes into both terms. We also know that a goes into both terms. So our common factor is 10a. What are we left with in the brackets? Well, if you take 20a squared and you divide it by 10a, 10 goes into 10 once and 10 goes into 20 twice. A leaves us with 1a over there. So we have 2a. What about in our second term? The second term is 10a. If you divide it by the common factor 10a, you'd just be left with positive 1. Great. What about in x to the power of 3 minus x squared? Well, here, the common factor you might be thinking is x. But let's see what happens if we take x. If you take x, in your brackets, what will you be left with? Well, imagine we took the first term, x to the 3, and we divided by x. Remember, this is the same as having x times x times x divided by x. What does this leave you with? It leaves you with x times x, which is x squared. And in our second term, x squared, if we divide it by the common factor of x, this is like having x times x over x, leaves us with just x. So we have minus x here. What do you notice? Well, what I want you to notice is that what's in the brackets can actually still be factorized. There's a common factor in there. The common factor is x. We say that this hasn't been factorized fully. That's why the question always asks that you factorize fully. Well, how do we factorize fully? Well, in order to factorize fully, when it comes to variables, you need to take the lowest exponent variable you can see in the question. What do I mean by this? Well, in this question, we have x to the power of 3 minus x squared. So the variable is x, and what is the lowest exponent that we can see here? Well, it's x squared, x to the power of 2. So you would take x to the power of 2. That's the lowest exponent we can see in the question. Now, if you take the first term, x to the power of 3, and you divide it by x squared, that's like having x times x times x over x times x. 2 of the x's disappear, and you're just left with x. If you take x squared and divide it by the common factor of x squared, you'd be left with just 1. So whenever you see a question like this, the common factor for a variable should always be the one with the lowest exponent that we can see in the question. In this question, the lowest exponent for x was x squared. And that said, when it comes to numbers, always take the highest common factor. You see here, someone could have said, what about 2? 2 goes into 20 and 2 goes into 10. But have a look what would happen if I took 2 as a common factor. In this term, 20a squared divided by the common factor of 2. 2 into 2 is 1, 2 into 20 is 10. I'd have 10a squared. Okay, let's say I had taken a common factor of, say, 2a, right? I'd be left with 10a, right? And what about if I took 10a and divided it by the common factor of 2? 2 goes into 2 once and into 10 5 times. Then I'd have 5a. Again, what do you notice about this bracket? This can still be factorized, okay? And so, oh, the a wouldn't be there. It would just be 5, okay? Because we're dividing by 2a. But this can still be factorized. There's a common factor of 5 here. And so because there's a common factor of 5, we haven't factorized fully. This is why it's important that when it comes to numbers, you take the highest common factor. When it comes to variable, you take the lowest exponent you can see in the question. And I'll type this out. When it comes to numbers, always take the highest common factor. Now, I do leave these notes in your comments. There's a link to a Google Drive for you to follow along and download these notes, okay? When it comes to variables, take the lowest exponent you can see in the question. Now, let's explore this a bit further with more examples. Imagine that we had 3a to the 4 minus 9b to the 3. Well, here the common factor is just 3. In the first term, I have 3a to the 4. That means I'd be left with a to the 4. In the second term, I have minus 9b cubed. If I divide it by the common factor of 3, 3 into 3 is 1, and 3 into 9 is 3. So you'd be left here with minus 3b cubed. What about in this question? What's the common factor here? We can see that x appears in both. But remember, we always take the lowest exponent variable that we can see in the question. In our case, that would be x to the power of 3. So we'd take x to the power of 3. In the first term, we'd be left with y. In the second term, you'd be left with x squared. If you took x as a common factor, you would not have fully factorized. You would find that your bracket could still be factorized further. There was still a common factor in your bracket. And so that's why we say to be safe, we always take the lowest exponent that we can see in the question. What about here? X to the 3, y to the 5, minus x to the 5, y to the 3. Both x and y appear in both of the terms. So our common factor has to do with both x and y. Now, when it comes to x, you have x to the 3 and you have x to the 5. Therefore, we're going to take the lowest one that we can see there, which is x to the 3. When it comes to y, we have y to the 5 and y to the 3. So we're going to take y to the 3. This is our common factor. Now, what are we left with in the brackets? Well, let's take that first term, x to the 3, y to the 5, and divide it by the common factor, x to the 3, y to the 3. The x to the 3's will cancel away. Y to the 3 will leave me with y to the 2. Remember, that was like having y times y times y times y times y. That's what we call y to the 5 over y times y times y, which is y to the 3. These cancel, those cancel, these cancel. You're left with just y times y, which we know is y squared. And that's why I simply cancelled this y to the 3 here and cancelled the 5 there, and we're left with just y squared. We're left with just y squared in that first term. And what about in the second term? The second term is minus x to the 5, y to the 3. And if we divide that by the common factor, which is x to the 3 and y to the 3, the y to the 3 is cancelled. X to the 3 leaves me with x to the 2. And that's what would have left there. Great. What about in this example? A squared, b to the 7, plus a to the 5, b to the 4. Well, our common factor would be a squared, that's the smaller of these two, and b to the 4, that's the smaller of these two. If you have a squared and b to the 7, that first term, and you divided it by our common factor, a squared and b to the 4, the a squares would cancel away. Sorry, it's actually, our first term there is actually a squared b to the 7, and our common factor is a squared b to the 4. These cancel away. Now, b to the 4 leaves us with b to the 3. So b to the 3 is what we're left with. And in our second term, we have a to the 5, b to the 4. If we divide it by our common factor, a squared b to the 4, the b to the 4 cancels away. The a squared leaves us with a to the 3. And that's what we have there. Great, let's have a look at this question. x squared y to the 10, z to the 8, plus x to the 5, y to the 3, z to the 4. Feel free to pause the video and try this out on your own and then compare our answer to what you have. It's always good to practice. Here, our common factor would be the lowest of the x's is x squared, the lowest of the y's is y to the 3, the lowest of the z's is z to the 4. In our first term, we have x squared, y to the 10, and z to the 8. When we divide it by our common factor x squared, y to the 3, and z to the 4, the x squareds cancel away. This y to the 3 leaves us with y to the 7 there. This z to the 4 leaves us with z to the 4 there. So what we're actually left with is just y to the 7 and z to the 4 in our first term. What about in our second term, which is positive x to the 5, y to the 3, and z to the 4? If we divide it by the common factor x squared, y to the 3, and z to the 4, then the z to the 4's cancel away, the y to the 3's cancel away, and the x squared leaves me with x to the 3 there. And so I'm just left with positive x to the 3. And there we are, we've factorized that. What about in this one? Here, our common factor, we could go with as a number 5, right? Because 5 goes both into 15 and 30. But we always go for the highest common factor when it comes to numbers. Remember how in that previous question there, we had 20a squared plus 10a. We could have gone with 2 because 2 goes both into 20 and into 10. We could have gone with 5. 5 goes both into 20 and into 10. But when it comes to numbers, we always take the highest common factor. So we went with 10. 10 goes both into 20 and into 10. In the same way here, we need to make sure that we take 15. 15 goes both into 15 and into 30. So when it comes to numbers, the common factor is 15, but we also have a and b appearing in both those terms. A appears here and a appears there. B appears here and b appears there. So they should also be common factors. We would take a squared because it's the lower of the two. We would take b to the 3 because it's the lower of the two. Great. What would we be left with? Well, in this term, we have 15 a squared and b to the 5. If we divide it by 15 a squared and b to the 3, 15 and 15 cancel away, a squared and a squared cancel away, b to the 3 leaves me with b squared. So all we're left with is b squared. The second term, minus 30, a to the 5 and b to the 3. If we divide it by 15 a squared and b to the 3, the b to the 3 would cancel away. 15 goes into 15 once, and it goes into 30 twice. A squared would leave me with a to the 3. So I'm actually left with minus 2 and a to the 3. Great. Last few questions here. Say you had negative 2x plus 4y. What's the common factor? Some of you may be saying it's 2. Some of you may be saying it's negative 2. And I'm here to tell you that both are fine as long as you do the maths correctly. See, if I took negative 2 as a common factor, I must make sure that the first term, negative 2x, is divided by the common factor negative 2. Now, negative 2 and negative 2 will cancel away, and I'm just left with positive x. The second term, positive 4y, if I divide it by negative 2, 2 goes into 2 once, 2 goes into 4 twice. So now I have positive 2y over negative 1. Now we know from our study of negative numbers that a positive divided by a negative is a negative. So this is actually negative 2y. So we must have minus 2y here. An alternative solution is someone could have said, well, I want to take positive 2 as a common factor. That's fine. The first term, negative 2x, if you divide it by positive 2, 2 goes into 2 once, 2 goes into 2 once. So you're actually left here with negative x. Okay? Then the second term, 4y, if you divide by positive 2, 2 goes into 2 once, 2 goes into 4 twice. So you have positive 2y. Both of these answers are actually correct. But as you can see, you have to be very careful with your signs. Here's another example. I'm going to take negative 4 as the common factor. In my first term, I have negative 20a. If I divide that by negative 4 goes into negative 20 5 times. Positive 5, right? And 5 times a is 5a. The second term, negative 8b, when we divide it by minus 4, well, negative 4 and goes into negative 8 twice. So I get positive 2b. Okay. Now, if I have negative x squared y to the 5 minus x to the 5 y to the 3, I can take negative x squared y to the 3, and in the first term I'd have positive y squared. In the second term I'd have positive x to the 3. Now, I want you to note very importantly as we close that factorization is the opposite of simplification. Why do you have to know that? Well, because it helps us to verify if our answer is correct. Imagine you were asked to factorize x squared minus x. Well, you take a common factor of x, open a bracket, and in the first term, if you take x squared and divide it by x, you'd be left with x. If you take minus x and divide by x, you'd get minus 1. But what if I asked you to simplify that answer? Simplify x into x minus 1. Well, we've learned how to simplify this. We'd say x times x is x squared. Then we'd say x times minus 1 is minus x. Look, this was actually the question we were asked there. So can you see that if you have this and you factorize it, you would get that. But if you have this and you simplify it, you would get this. Factorization and simplification are opposites. So when you're done factorizing a question, when you get to this point, try to simplify this and see if you go back to the question. So for example, if I was told to factorize 2x minus 4y, I would say the common factor is 2, and I'm left with x minus 2y. If I want to check whether my answer is right, I will simplify this to see if I get the question back. So 2 times x, that's 2x. 2 times negative 2y, that's negative 4y. There we are, I got the question back, and so I know that this is a correct factorization. You don't want to show that in your working because they're going to think you're confused about what factorization is. You can do it on a piece of paper on the side. Simplify your answer, see if you get the question back. If you do, that means you're factorized correctly because simplification and factorization, they are opposites. In all the questions that we did from the beginning, if you try and simplify this, you should get that. That's how we know that we factorized correctly. Let's see, just for this one. 2 times x is 2x. 2 times positive 5, positive 10. We've correctly factorized because we got the question back when we simplified. Great, grade 9s, 10s, 11, 12s. I hope this video was helpful and see you in the next one where we discuss the difference of two squares.